Hey, welcome back everybody. We're going to be discussing the distance formula. When we talk about distance formula, we're talking about mostly on a coordinate plane. Okay, so there's two different ways that we can have distance drawn. We can either have it drawn nice and across our units perfectly, including vertical, where we can just count the units easily, and we also have one distance where it would be going not across them directly, but diagonally through them, so it's not as easy to count those units. So let's think about the two different ways that we can do this. We're going to discuss the ones that go really easy first. To find the distance from A to B, it's just the difference in their location. So wherever B happens to be, if we find the difference, we'll be subtracting whatever A is. So the distance here would just be B minus A. That's linear distance. Now when we start talking about distance on a coordinate plane, as in here, we have to think about the coordinates themselves of these points. Okay? If we think about having this particular coordinate as x1, y1, and we're trying to find the coordinates of x2, y2, let's think about this in terms of a triangle, right? The distance is always going to be a squared plus b squared equals c squared. That's the Pythagorean theorem. So when we talk about the distance, we have to think about vertical distance and horizontal distance. Okay? We need to figure out the length of b. Well, the length of b is going to be whatever this distance of b is according to our x coordinates, because that's what goes left and right. So that would be the distance between x2 minus x1. And the distance for A, we would notice, goes with our vertical, which is the difference between y2 and y1. Now our formula tells us that we're adding these things together and we're squaring them. And that's going to end up giving us c squared. Well, we want to know c by itself, so we're going to take the square root. So the distance formula for a coordinate plane is going to be, I'll write this in alphabetical order for you, x2 minus x1 squared plus y2 minus y1 squared. So this is the distance formula. Very important, very useful. We will be using this a lot more later on in the semester, but for right now, don't forget about this. And this is the linear distance. A little bit easier, I think. Okay, so let's look at a couple of examples. Now, these are kind of wordy, but they're pretty easy to work with because we're only using one particular vocab term here. It talks about midpoint. Now, midpoint has to do with lines themselves. So, I'm going to draw myself a line. And when I notice the problem, it says that T is the midpoint, or the middle, of QR. Line segment QR. So I know my ends are going to be Q and R, and somewhere in the middle is going to be point T. Alright, then it tells me that V is the midpoint of TR. Well, here's TR, and in the middle is going to be V. And lastly, W is the midpoint of TV. Well, here's TV, that would put the midpoint W. They want us to find the length of QW if WV is 5. Well, we've drawn our picture, but let's think about what it means to be a midpoint. It means that these lengths on either side of the midpoint are congruent. So when we look at W being the midpoint of TV, we know that TW is going to be congruent to VW, which means that TW is going to be worth the same amount, which is 5. And if V is the midpoint of TR and TV is these two, which is 10, that means that VR has to be worth the same amount also, which is 10. And lastly, QT, the midpoint, has to be equal to TR, which is 10 and 10, which gives us a length of 20. Now, they want us to find QW. QW consists of 20 for QT and 5 for TW. So if we add those two lengths together, we find that QW is 25. Okay, I have another problem right here. You can try it out on your own. Again, draw it out first, label, usually if you think about it going backwards from the smaller piece and then thinking about what it means to be a midpoint, you label everything first, it makes it a little bit easier. So try that one out. We'll discuss it in a second. Alright, let's see how you did. So it tells me that T is the midpoint of LM. So here's my line. Here's LM. T is right here in the middle. B is the midpoint of TM. TM is right here, so this means B is located there. P is the midpoint of TB, so here's TB. That's the midpoint. And lastly, Q is the midpoint of PB. Now here's Q. And it says that if QB is 2, find LQ. That's what we're trying to find. Well, Q is the midpoint of PB. That makes PQ also worth 2. P is the midpoint of TB. If TB is 4, that makes TP also worth 4. And B is the midpoint here. We have 4, 2, and 2. That gives us 8. That makes BM worth 8. And then lastly, LT is 8 and 8, which makes this worth 16. Now let's look for LQ. LQ covers all of this. Covers 16, 4, and 2, which if we do our math correctly, that gives us a length of 22. Alright. Now we're going to look at the problems that have to do with the distance formula. Okay. Again, let's take a quick look at it. It says that we need to have x2 minus x1 squared plus y2 minus y1 squared, and then take the square root. Well, here's what I'm going to do, and I do this every time I do these problems. Guys, I've been doing this for a long time, and I still do this. Why? Because why take the risk of making a mistake? I'm going to label one of them as x1, y1. I'm going to label the second one as x2, y2. Again, if I have them labeled, I don't have to take the risk of making a mistake. Alright, so the distance formula, I'm going to rewrite it down here so we can actually see it. It tells us that we need to take x2 and subtract x1. Well, x2 is 1 minus x1, which is 6. And we're going to square that. And it says y2, which is 8, minus y1, which is 13. And we're going to square that. Okay. Well, 1 minus 6 is negative 5. And 8 minus 13 is another negative 5. We know that we have to square these things. Negative 5 squared is positive 25. Another negative 5 squared gives us another positive 25. Now, the reason why those are positive is because we're multiplying a negative twice. That gives us negative times negative, which we know is positive. Okay, so the nice thing about these is they're always going to give us positive numbers, which is good because distance has to be positive. Okay, last, we're going to add those together. We'll get the square root of 50. Now, for right now, this is fine. Okay, if it was a perfect square, I would want you to simplify further. For right now, we can leave this as just the square root of 50. Pretty soon in the year, we'll talk about how to simplify that even further. Alright, so here's a new problem that you can try out on your own. Okay, this is -3, 5 for A and 4, 9 for B. So try that one on your own. Alright, let's check it out. We know distance is going to be, well, x1 and y1, x2, y2. Almost forgot. We know it's going to be x2 minus x1. So 4 minus -3 squared. And y2 minus y1 squared. So 9 minus 5 squared. Okay, I see a double negative. That's 7 squared. Plus 9 minus 5 gives me 4 squared. 7 squared is 49. 4 squared is 16. If I add those together, that's going to give me 65. So the distance of AB is going to be the square root of 65. Now, you will see problems in the homework that ask you to prove triangles congruent that have coordinates, and you're going to have to use the distance formula. Think about it this way. If you have triangles with specific coordinates, you can find the distance of each of these sides using the distance formula. So if you figure out each value of this side using the distance formula, you can then check the second triangle and see if you can match them side for side. If you have a side that matches, you would continue and check the next side to make sure that it matches another side on the triangle, and check the third side. If at any point after you complete the first triangle you come up with a different number, then obviously the triangles wouldn't be congruent to each other. So you find the side lengths of one triangle first, then go to the next triangle and try to find all the sides. If you come across one that's not congruent, the triangles themselves aren't congruent. Okay, that's it for the distance formula. We will be coming back to this a little bit more later in the year, but for right now, this will do.